Okay. So I am going to invite everyone to a coding rooms classroom. So we have 4 people, so that's great. So I just put a link in the chat. So if you'd like to join and follow along, you can. You don't have to. This is all going to be recorded and you'll have access to this classroom whenever you want to explore it. So that's really up to you if you want to join right now or do it later.
Hey, John, do we click I'm an instructor or admin or I'm a learner?
Just do I'm a learner for now.
Okay, thanks.
There's not really any difference as far as, we're concerned right now. I don't think you're going to go in and change anyone's grades. But I would do that if we were sort of doing a lesson on how coding rooms itself works so that you could do some grading. But we're not really going to focus on how coding rooms works right now, except, with respect to showing graphs and things like that. So. All right, so I'm also going to go ahead and share my screen. As I mentioned, I'm going to kind of walk through this. I want to say right off the bat that there is no possible way that we could actually cover all of data science in an hour. So this is really going to be a quick sort of high level overview of things you can do with coding rooms and with Python and NumPy and Pandas and Matplotlib and Seaborn. But I'm not going to have time to go like super in depth to everything. That being said, if something doesn't make sense to you, if I'm going to quickly, feel free to ask questions, please. If you have a question, probably other people are having the same question. So definitely, just chime in whenever you want or put a question in the Zoom chat and Joe will yell at me and make me stop. So I want to start off with a little chart that I made. And let me get rid of this for a second so I can get here. And this is how I explain what data science is mostly to other high school teachers and who aren't familiar with it or just starting to get into it. So I use this Venn diagram and you have access to it on the resources page in the classroom. So I see data science as a combination of a lot of different things. And I, in fact, say that data science is probably the most powerful tool for equity and social justice that we've ever had. So that's kind of what that middle, I don't know what the shape technically is, a kite, I guess. But it's a combination of social studies, math, science, computer science, and ultimately data science with social studies to really think and show connections between, the history and the present and the future, and just really bring it to life. I think a lot of students feel disconnected from things like social studies, just memorizing names and dates. But I think with data science, you can compare The French giving arms to the Americans for the American Revolution, and Americans giving arms to Ukraine for protecting themselves against Russia. I think there are a lot of things you can do with data that really, bring things home. So this is what I use to explain data science. Again, I'm not going to go through every quadrant there. I have also spent a lot of time looking at different types of data science curricula. This is my,
John, while you're over there too, can you just publish these pages for everyone?
Oh, I'm sorry, I didn't click publish yet. There we go. If you don't have Google Tables, then you won't be able to open that, and I don't have on this account, so I'm going to bring up my Google Sheets. So you can see that I have about 31 different categories or different curricula here. Some of them are full curricula, and those are the ones at the top. It's if we sort the whole thing, actually, I don't know why it's not sorted by that. Right, so these are the full curriculum from come on, let me do, it won't let me do that. All right, so there's from all sorts of different universities. There's Bootstrap, there's code.org in there. They've got one unit on it. Microsoft has one. Runestone is a free. So all of this will tell you what technology they're using, if they meet any specific standards. Sometimes that's specific state standards, which may not apply in your particular state. So you might want to look at that. What kind of cost it is. So CodeHS, for example, has a free version. But if you want to have a grade book and assignments and things like that, then you have to pay $2,600 or $2,700 a year. A lot of these are free. And then as you get down, it gets into individual projects, specific tools like CodeApp you may have heard of, or just individual projects that you might want to throw into a class. So that another thing that I believe strongly in is de-siloing computer science, as you can probably tell. So if you can get other teachers in math and science and social studies to use data science in their classrooms, there's a lot of good units in here that you can just steal. They want you to take them and use them. So so that's a great resource. And then here are some that I use in my data science classes. Coded Bias is a great movie. I think I don't know if it is right now. Off and on, it's free for schools. We just got a new link for our school that made it free. So I would contact them at this website. I have my students read Weapons of Math Destruction, which is a great book on how, even though people think about data science as being objective because it's programs, it's computers, how can they have bias? If you're putting biased data to your models, then you're going to get biased results out. So you have to look very carefully at what data you're using. Nice do no harm guide. There's a newsletter called Data is Plural. And then this I use a lot is Kaggle. They are the premier source for data sets now. So if you go to Kaggle, you can see that they have data sets for every possible kind of things, hundreds and hundreds, thousands of data sets. Social media influencers, is news fake or real, commodity prices, and you can sort it actually by, so let me pick one of these, by their usability, right? So usability here is 7.65 out of 10. So what does that mean? It means there might be some missing data. There might be some mismatched data. So like, if you have a column of numbers, some of them might be typed out, O-N-E, and some might be numbers, the number 1. So 7.65 is decent. It's not great. They have a lot of data sets that are, 9 and higher. So if we wanted to do something on, I don't know, education, TED Talks here, usability 10. Male and female by country, usable 10. Students' math scores, usability 10. World university rankings, right? Shark data. So there's like anything you can think of, anything your students want to learn about. That's why I love it, is because the students really have agency when you say, pick your own data set, look for something you're interested in. A lot of them, there's a lot of sports data sets in here. There's a lot of music data sets, top songs on Spotify, that kind of thing. So really, it really is authentic data that gives kids agency in their coursework. So we're going to talk about 4 different tools. I'm going to assume that you have a little bit of background in Python, because I'm not going to talk about structure of Python or loops or conditionals or anything like that. I'm just going to basically explain the different types of code that I'm using. So NumPy, and here's a link to more information about it, is the mathematical library for Python. So one thing you'll always hear, oh, Python is slow, Python is slow. It's not slow. And we can get into an argument about that later on if anybody's interested. But if you're using massive amounts of data, like millions or billions of data points, any scripted language like Python itself would be slower than a compiled language like C. So what a bunch of people did was, well, they said, we can make a library in C that Python can then import. And that is NumPy. So the library itself is a compiled C library that Python imports, and it makes sure that memory is contiguous and like all these other tricks under the hood to make dealing with numbers really fast in Python, faster than you could do with standard Python lists and dictionaries and things like that. Pandas lives on top of NumPy and is specifically for data analysis. So I can't remember what it stands for, but it's stands for anyway, something about data analysis and structure or something. I don't remember what it stands for, but anyway, it's the data analysis library, and its 2 main data structures are a 1-dimensional and a 2-dimensional matrix, and has a lot of functionality that makes it really easy to manipulate that kind of data, right? It assumes you have, for example, headers across the top of your two-dimensional matrix, and it assumes you have an index down the left-hand side for each row, right? And if by default, if you don't have indices, then it has a numbered indices, 0, 1, 2, 3, 4, 5, like row numbers, like Excel. So the idea is to, in a programmatic way, make data as easy to use as though it were in Excel, but do it in a way that is extensible to millions and billions of rows in real time. Unlike, Excel. Excel is great. Don't get me wrong. I love Excel for a lot of things. But once you get into real data analysis for bigger data sets and real-time data analysis and things like that, you just, it gets beyond the abilities of Excel. And then in terms of visualization, we're going to talk about 2 libraries. One is Matplotlib. And if any of you have ever used MATLAB, that will look familiar to you. It has a lot of the same functions. Again, it's pretty low level. It's designed to, it was originally designed to make plots that you would put in academic documents. So it's robust and fast. It's not the prettiest thing in the world. But if you're doing basic stuff, it's great. And then again, Seaborn is a library that is built on top of Matplotlib that abstracts out a lot of that drudgery and makes it really easy to make really pretty graphs, really beautiful, elegant graphs, and makes it easy to change the way things look and how they're plotted and things like that. So this is what we're going to go through in the next half hour or so. So you can see there's a lot there. So any questions right off the bat here? Panel data analysis. Thanks, Ed. Yes. Netflix has Coded Bias. Yeah, great movie. Watch it every year with my classes. Okay. All right. Then, oh yeah. So last thing here, I have included a Google Drive link to Python for data analysis. This is the book about working with pandas, NumPy, and IPython if you want. Pandas was created by Wes McKinney. You may notice his name on the front of this book, and is now open source. So it, you can go in and help out developing it if you want. But this really, it literally goes from, what is IPython, what is NumPy, what is pandas, how do you install it, how to use the basics of the Python language. It's not, it doesn't teach you Python, but it does go through a lot of the basics in terms of what different data structures are, how to, I would consider this more of a reference for Python than a learn Python book. But if you're already somewhat familiar, this is a great sort of refresher and reference. And then he gets into exactly what NumPy and pandas and everything do. So I would highly recommend this book. Obviously, you can get it in PDF. You can get it in ebook. You can buy a paper copy if that's your thing. And that, I love programming books. I have a whole shelf of them that I've never actually opened or opened once. But this is, if you want to learn this stuff from scratch and really go through it step by step, I highly recommend this book. It's, in my opinion, the best one out there. All right, so let's do a little bit ourselves. Here is NumPy. So it, as I mentioned, is mostly written in C. And it does a lot really fast with arrays. So I made a little example program here. And if you're familiar with Python, you can see that I made a list. Here, let me get, oh, I need to publish this as well. I haven't published any of these. Let me publish all of these so I don't forget again. Okay. Just want to, there we go. All right, so hopefully you can see this a little bit better. So I made a one-dimensional array, and all I did was create a list in Python, and then I used NumPy to make it into a NumPy array, and then print it out. So A two-dimensional array, I do the same thing. If you're familiar with Python, this is a list and this is a list. So what this is a list containing two lists. And unlike Python, it's really easy to do functions on that matrix because they're built in. That's what NumPy is for. So we're going to get the minimum value in that matrix, the maximum value, the mean, and the standard deviation, all with just one simple call each. So if I run that, you can see here's my one-dimensional array. And the cool thing about NumPy, when you print out a multi-dimensional array, it pretty prints it for you. So that's a nice feature there. It looks like a matrix, which is what it's expecting you to use it for. And then again, the operations are super easy. Minimum is 1, the maximum is 6, the average or the mean is 3.5, standard deviation is 1.7, blah, 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 blah. So it's super easy to use NumPy. It has all the functions you'd think it would have. We don't use it a lot in data science because, as I mentioned, it is the foundational layer rather than it's requires a lot of knowledge and a lot of grunt work to use it directly for a lot of things that you want to do in data science. So what we use instead is pandas. So here we have pandas, and this is really what we're interested in looking at. So I'm going to make this a little bigger. And this might look a little bit confusing when you first look at it. But what we're doing is we're setting up what's called a data frame. And the data frame is the fundamental object type for pandas. It is essentially your Excel worksheet. It has rows and columns like you're used to, and it has indices for both the rows and the columns, optionally. You don't have to have named indices, but it makes things a lot easier. You can put any kind of data you want in each column and row. So in this case, here, I'll just run it because it prints out the entire data frame. So let's just look at what this looks like. It's because of the small screen, it's scrunched it up. All right. Well, what it's done is it said the leftmost row is going to be my index. It's going to be mammal. And then each row's name is going to be one of these. So the first thing I'm putting in is the left-hand index. So my row index. And then for each one of those, I put in a column, the lifespan, the hours of sleep, the speed, the diet. I can put in as many columns as I want for all the elements in that first column. So this is just a Python dictionary right now. Whoop, that's not a data frame yet. That's just a dictionary. To make it into a data frame, we call the function DataFrame. And I've just imported pandas as PD. This is kind of the standard way to do it. So I say PD pandas, essentially, create a data frame from this data and call it mammals. So it's just taking this dictionary and making it into a data frame that then I can use all these cool pandas features on. So if we go through, let me see if I can make this look a little better. 1 second. Oh, we have questions in the chat. Right. So Ed's comments are 100% correct. One other thing that NumPy does is it actually works really well with modern graphics hardware. So if you are doing a lot of integer-like computation, like machine learning and artificial intelligence, it can actually make use of your hardware acceleration. Yes, that's also a good point. You can do n-dimensional arrays. You don't have to limit yourself to 2-dimensional arrays, but that is kind of beyond the scope of this discussion right now. All of these, like I said, you can put any kind of data type in here. It doesn't have to be integers and you know, strings or floats or whatever you want. You can put lists in here. You can put dictionaries in here. You can put whatever you want in your array and make it multi-dimensional. And pandas or data frames will help you deal with that. So I'm just going to set it to show all the columns. Let me start sharing again. All right, again, I'm on a bit of a small screen here, but this should help. There we go. So I just put in this display max columns. So it will, instead of truncating them, it will actually let me, it'll actually show all the columns here. So this is my data frame. You can see that it matches the dictionary that created it. So mammal, I have African elephant, dolphin, cheetah, cat, and those are the indices along the left-hand side here. Then I have a lifespan. Each one matches the appropriate mammal, hours of sleep, speed, and diet. And again, you could have this be a multi-dimensional array. You could have other objects in here. You can put whatever you want in a data frame. But we're going to stick to basic data analysis for now. Data types will show you what they are. So anything that's a string is just listed as an object. Those are integers. The data frame itself is an object. The shape will tell you how many rows and columns it has. The stats will be printed out here with the function describe with 1 decimal of precision. So you can see each column, the lifespan, hours of sleep, and speed. Obviously, it doesn't do you know, the average diet because that doesn't make sense. It's not a number. So you can see how many there are, the mean, standard deviation, and then the quartiles. Prints out the first 5 rows, the last 3 rows. And then there's lots of different ways to index a data frame. So again, we don't have time to go into every function of a data frame, but these are the most common. Some other common ones are using locations. So you can specifically say, you know, the locations where lifespan is greater than 10 years, or hours of sleep is between 3 and 8, or you know, you can use the numbered indices. You can say, just give me rows 3, 4, and 5, or column 2 and 3, or whatever you want. You can slice and dice, and it's, you know, there's functions for basically everything. So whenever you're looking at data sets, the data frame will have a lot of different ways to help you. It also, speaking of less reliable data, once you start, or your students start getting data from Kaggle that is not 100% filled in and perfect, data frames do have functions to help you with that. Data cleaning is a whole unit, multi-week, you know, unit on what does it mean if, you know, I'm looking at lifespan for each country in the world, and one of the countries says the average lifespan is 582. What do I do with that number? Right? Do I delete it? Do I make it an average of its neighbors? Do I try to figure it out and correct it? What does that mean, correct? So there's a lot of data cleaning that any good curriculum will address. So that is an important topic, especially with regards to you know, what you read in the news. I think if you're talking about data science in terms of people reading statistics in the news, you want to have your students think about, what does it mean if the data is not 100% reliable? What could be going on behind the scenes there? So cleaning the data is definitely an important step in the data science lifecycle. Okay, so let's carry on here. All right, so those are sort of the text-based tools for data science, NumPy and Pandas. Do you have any questions right off the bat? I'm going to give a few seconds here to see if anyone has specific questions or comments or corrections. Okay, I don't see any hands up or any new chats. Okay, then I will continue on. So like I said, Matplotlib can do a lot. A lot of people will just use Matplotlib. You can see I have a little list here of the most common things that people do with it, usually for incorporation into academic materials. Well, I don't know if that's true. Originally, as a way to not use MATLAB, so that you could do similar things with Python. That was its original, you know, goal, and now it's expanded. It's this huge project, open source project now, and there are, you know, hundreds of projects that use Matplotlib as a foundation, from, you know, geographic tools to 3D modeling tools to, I mean, you can, you know, if you go into the resources and go into Matplotlib, you know, they have they'll have a complete list. Here's some things you can do with Matplotlib. Well, thought I saw a list of all the other things that use Matplotlib as a foundation. But anyway, so here's Matplotlib, and here is a another coding example. This uses NumPy and pandas, so that's why we started with that. This actually reads in data from a CSV file. So this, again, is a super powerful abstraction that makes your life really easy if you decide to use pandas, because pandas has a built-in read CSV function, and it takes a CSV file and makes it into a data frame in one step. It's just, I mean, it's just super easy. So oh, let me make this big again so everybody can see it. So what I'm doing here, I'm reading this data.csv file, and what I am using is the scores of SAT tests. Is it SAT or ACT? SAT, I think. Anyway, yep, SAT scores. And you can pretty much guess what all this does just by the name of the function. The grid is on, it's true. I set the title, the font size, set an X label and a Y label, and then I make a histogram, right? It takes the data, cuts it up into 10 bins, determines the, oh, this is just to print out the mean, median, and standard deviation. And then this is just so it sets up reasonable X axes, right? So that it doesn't, you know, it's stretched out to 3 times the standard deviation, which is typical for, you know, histograms if you're used to this kind of thing. It creates the x-axis values, it creates the y-axis values, and then it plots it with a color orange and a line for the distribution. So I will run it. And this is something you have to remember. In coding rooms, right, it's going to run your program. And so it's going to print out the mean, the median, and the standard deviation here. And then I just, you know, print out some other stuff down here. But when you have a plt.show, it doesn't pop up anything on your screen like it would if you were running it in VS Code or, you know, any other desktop IDE. So what you have to do is you actually have to look over on the right-hand side here and click View Desktop. If I click it right now, it's going to make a tiny little square in my screen. So I'm actually going to pop out the desktop using this button right here, and it'll open it in a new tab for me so that you can see the 10 bins I created and the distribution line. So this is, you know, your standard histogram. It really does not take a huge amount of coding. You know, I read in the CSV file, created the data frame. I added the labels to the graph. I plotted the histogram. And then I added the distribution, the line as well. And that's it. The rest is just, you know, we don't even need to have this in here, actually. This doesn't add anything. So now you can tell a data story, right? You can look at this graph or this chart, sorry, and talk about it, right? This gives you a much better idea of what's going on than trying to look at these scores. Right? And the big thing with data science is telling a story in a way that people can understand. Right? That is, in my opinion, at least, the whole point of data science is to take a bunch of numbers and make them meaningful to other people, to communicate some kind of meaning from this, right? So what that meaning is definitely, up to your interpretation, whether it's, look at what averages or means are, what, how many people get high scores or low scores. So that's the first step in any case. Of course, we can do more interesting things. We can do correlations. So, somebody had a chat. Do you have to create a data frame before you plot them? You can use other data objects. You can use other kinds of arrays. So you don't have to use pandas to use Matplotlib, but it does make it easier in general. Right. So here is, Olympic swim times versus the year, right? And so we're going to do a little correlation here. We're going to, make this big again. Make this smaller. So again, the correlation here is going to be super easy because, again, we're using a data frame. And so it's set up to do this. You just use Y, right, which is the minutes. Find me the correlation with X, which is the year. So at this point, I would ask my students, what do you think the correlation is going to be between, the year here, 1924, all the way up to 2016, right? It's Olympic years, so there's only 22. Well, what do you think is going to be the correlation between the minutes or the seconds and the year? And hopefully they would say, well, we expect it to have a negative correlation, right? We expect the swim times to come down over time. And so then they would, be doing this. I wouldn't have filled all this in for them. They would be doing this themselves. And then I would view desktop. And sure enough, here's my line of best fit. Now, again, this is where data science gets interesting. Why do we think, obviously it's not perfectly correlated. It's not, the dots don't make a straight line. It's pretty steep at first, and then it starts leveling off. And then, it's interesting to talk about why it's not a straight line. What do you think the next data point is going to be? Right? Can you predict what the 2020, in this case, would be based on these? Right. So that is what a lot of people would do next, is try to predict, outside of the range, what is the next winning time going to be. All right, I'm running out of time here, and I still want to get to Seaborn. So I'm going to skip ahead here. So Seaborn, as I mentioned, is based on Matplotlib. It gives a little bit easier interface, both for creating the charts, but also for making them look nice. They have, a lot of ways to export to, HTML and things like that. So the data that I have here, the last time I used it was 2020 COVID data, so I don't have it up to date. I guess I could go ahead and do that, but I'm going to go ahead and run it. And I'm going to show number one first. So I have 4 different charts here that I'm going to show. The first one, we're just going to look at some data points. So let me show you what the data looks like here. It's a semicolon separated instead of comma separated, which you sometimes might get. So all I had to do here was say the separator is a semicolon instead of a comma, and Pandas doesn't care what you use as your separator. So we have a country, there's no subregions, we have the date, latitude, longitude. There is missing data in here. Obviously, there's a lot of zeros in here. But confirmed cases and deaths, right, is what is going to be shown on this particular chart. We're going to look at a specific date, March 29th. We're going to filter by country. We're going to group by the country so that it conglomerates all the data from each country into one group. It's going to sum it, right? So each country's total confirmed cases and total deaths is going to be summed into one value. And then it's going to sort by confirmed cases. So if I run this, right? So on the bottom, it's sorted by confirmed cases. And on the y-axis, it's number of deaths. Not a super useful chart. You would expect it to have a positive correlation. You could talk why are there some outliers here, but it also doesn't really show you which country is which and things like that. So it's only marginally useful, but I just wanted to show basically how easy it is to look through, to filter, based on specific data, select a certain date, group by a country, aggregate it by the sum. You could do average instead, or, whatever you wanted. So in a single line of code here, in a single query, you can get exactly the data you want. And then create a scatter plot. So this SNS is Seaborn. That's the standard way to import it. We create a scatter plot with the data we just selected. We set I don't like that word, deaths, confirmed cases, deaths, and that's the title. The next one is a little more interesting. So I'll show you number 2 here. This is a familiar graph to most people. So this is the cases in China by date, so February through March of 2020. And there we go, confirmed cases. So from 0 to 700,000 in, a month or 2. So that tells a data story. That's a little bit more, on point. And we can easily update this to go through 2022 and talk about what the ups and downs mean since then. All right, number 3 is aggregating data. So again, we're going to group by date and country in this case. We're going to sum it all up, but we're only going to look at US, China, Italy, Spain, and France. So we're going to filter on date, country, and confirmed cases. We're going to sum it up basically by country and date. And we're going to look at a line chart, right? A line plot of cases by country. So here you can see again, now we're starting to get into interesting data stories, right? China, if you remember, had a huge spike at the beginning and then it started leveling off. France, Italy, Spain, US, if you remember, was actually lagging the rest of the world for quite a while. And then we didn't lag the world for quite a while. So again, interesting data stories to talk about here. And then finally, the last one here, just to show you a different way of showing data, is we're going to just look at the top 15 countries. So we're going to use several pandas methods chained together using our data frame. We're going to query it down to just a specific date. We're going to only retrieve the data, the variables that we want, and we'll aggregate it again, just like we did before. And then we'll sort it so that we can see it in a nice way that makes sense visually to us. And reset index is just because in the original data set, right, the countries are all over the place. So their indices might be like, 148, where we want to reset it based on the sorting. So it's sorted in order and the indices match that sorted order. So this is what it would look like. Sort of the initially way you might set it up, confirm cases on the left and countries on the bottom. And Seaborn does all this nice coloring and everything for you. This doesn't look great because the countries all overwrite each other, especially if you have it in a smaller box. So in this particular case, we might want to have the countries on the left and the confirmed variables, on the x-axis instead, because it looks better. So literally, we can just change this. And run it again. This desktop should just update. There we go. So some data scientists might yell at me for the way that I have this, the X and the Y variables. But I think it looks better like that. And you can change the coloring, right? This is just the default. We could make it from green up to red or something like that really easily with Seaborn. Yeah, you could easily spend an hour just playing with the different this one function, set theme. You can make dark themes, light themes, gradients, different fonts, different types of lines on them. It's it's amazing what you can do with these 4 different libraries. So, and then I included here at the end, USA COVID data from Kaggle, and I made them little assignments, which you're welcome to steal if you want. Oh, the file didn't. Oops, that's the wrong one. Upload. Oh, there it is. I'll just rename it. So here is recent, just American COVID data from Kaggle. And they keep this updated, so you can re-download it anytime. And always a fun thing to do with students. They love spurious correlations. So your assignment is to show the spurious correlation in at least one of the data sets. And the ones that I included in here are number of people that die by being tangled in bed sheets versus number of pounds of cheese consumed on average in America. in these years, and you'll find that they are actually very tightly correlated. Number of divorce or percentage of divorce, the divorce rate in America versus pounds of margarine consumption, again, very tightly correlated. Number of Nicolas Cage movies that came out versus a number of people that drowned, also highly correlated. So it's pretty fun for the students to come up with theories on, why margarine causes divorce or why divorce causes people to eat margarine. But always fun. And that takes us to 8 o'clock. So if anyone has any questions or comments or anything like that for me, I'm happy to point anything else out, more resources, anything like that. This video will be published. The link will be published with the video to the classroom, so you can easily copy this class as well. And just copy it over to your own account so you don't have to use mine. Coding Rooms is great for stuff like that. And, as usual, if you're not familiar with all the tools of Coding Rooms, definitely jump on one of those webinars, because you can see what all the students are doing at any time. I honestly help them even in the evening sometimes, because that's when they're actually doing their homework and they need help. You can just jump right on and help them right there. So it's just a super powerful tool.
John, may I ask a question?
Yeah, of course.
Are you using Coding Rooms in what computer classes? Is it Intro to Python, or is it like APCS principles?
I use it for everything except for my hardware course. So I teach JavaScript, although to be fair, I mostly use VS Code with my JavaScript class, but I start them on Coding Rooms when we're just learning about it. I use it for my intro to Python. I use it for data science with Python, and I use it for APCSA.
Okay. With Java, right?
With Java. And one thing you should know about, here I can share my screen again, is there are a lot of curricula already in Coding Rooms. So let me share my screen again quickly. So when you log in, you won't have as many classes as I do, but if you click new course, you can create from an empty template, but there are already all these other courses here. APCSA.
Yeah, that's interesting, because I signed up. I think I only see, was it 2 or 3? I forget. But I saw the Intro to Python, but I don't know how to get some of these other ones. Yeah.
They should be showing up for you now. If you looked a while ago, they might not have been there, but we're adding more like every month.
Okay.
And CS Awesome is great. If you're teaching APCSA, I've used this for several years and I love it. I think it's a great, and they're super responsive, great, email group. So
do you use the auto grading feature if the students hand stuff in, or how reliable do you find it?
Super reliable. I have several webinars on the auto grader that are on our YouTube channel, and I'm sure we'll be offering it again. But
I'll be checking that out, because most of them are finicky.
And there's
a popular word, finicky.
There's lots of different ways to make them more or less finicky, and we definitely cover that. So definitely.
But on the same vein, train of thought, is there any plagiarism checkers?
There is.
I'm sorry, there are, but is it built in? Can you turn in a little checkbox, say plagiarism checker?
So That's one of the things that we are working on. It's
Mhm.
not built in yet, but they're definitely working on it. One thing that I have used
Mhm.
is the timeline. So
Yes,
you can see second by second or click by click or whatever what a student has done. And so if it looks like they're typing and then fixing and typing and fixing, and then they test and then they fix, you're like, okay, they worked on it. If they do that for 5 minutes, then there's a half an hour break, and then they have a perfectly working program.
right.
You go,
Yeah, people have turned stuff in and it's like, wait, you downloaded the instructions and you uploaded the answer in less than 2 minutes. Like, you can't read the instructions in 2 minutes. So it's like, I'm not taking it. And they get upset. It's like, how do you know? It's like,
oh, I
don't be
just
so
say,
obvious.
okay,
Yeah, don't be so obvious.
explain to me how it works,
Exactly.
right? Walk me through your code.
Mhm.